So now let's begin with the different types of functions that we have. Firstly, equal functions. What are equal functions? Again, two functions. Let's say we have f as one function, g as one function. They are said to be equal if they have the same domain, they have the same codomain, and f of x is equals to g of x for every element in their domain. That means, what are we trying to say by this statement is that the output values of x for x in the function f of x and in the function g of x should be same. Then only we can say that the two functions are equal. Now talking about polynomials, again, polynomial is an expression which is made up of variables and coefficients involving only addition, subtraction, multiplication of constants in it. Now those constants can be either positive or negative. Now if we look at the general form of a polynomial, it is shown in this format. Now we will study about polynomials in detail when we study quadratic equation, which is the chapter right after this. There you will see, we'll study how these constants and what are the basic classifications of polynomial. So generally, whenever you see a polynomial function which is in this format, here you must remember one thing, that n, or the power that we are writing here, the powers of x should always be a whole number. Should be whole number. Let's say if it is not a whole number, then it cannot be classified as a polynomial. Then it would become some other function. So keep this thing in mind. Apart from that, if we were to talk about the domain of a polynomial, it is generally R. All real values ranging from minus infinity to plus infinity. Or this can be written as minus infinity to plus infinity. This is my domain. Now when we talk about range of polynomials generally depend on whatever the function has been given to you. Sometimes, let's say if you have a cubic function, how does a cubic function is represented as? It is represented as y is equals to x cube. Now of course there can be other terms as well, and for the time being, just to explain it to you, I'm taking this example, y is equals to x cube. So what would be the range for this? It would again be R, which is minus infinity to plus infinity. If you look at the graph of a cubic polynomial, it is generally of this format. And whenever we look at quadratic equations, let's say, again, polynomial can be transformed into a quadratic equation, right? Which is of degree 2. That means the highest power of x is 2. So let's say if I have a quadratic equation, ax square plus bx plus c is equals to 0. So how do the graphs of quadratic equation look like? It is either an upward parabola or a downward parabola. It is an upward parabola when a is greater than 0 and downward parabola when a is less than 0. Now again, these things might seem a little vague for you because you haven't studied quadratic equations till now. When you study quadratic equations, these graphs and equations would become fairly simpler for you. Now generally, what do we write down the range for any quadratic equation? The range, because the vertex of a quadratic equation has whatever be the x coordinate, we are not worried about that. The y coordinate is generally minus delta or minus discriminant by 4a. Here also the same thing, x comma minus discriminant by 4a. So your range would become, let's say if you have a greater than 0, so your range would become minus d by 4a up till infinity. So this is how range of any polynomial is decided. So keep these things in mind. Now talking about rational function. Rational function is basically the division or the ratio of two polynomials. So here, as you can see, f of x is p of x upon q of x. So again, we know both of these are polynomials. One thing that we can say about the domain is that qx should not be equal to 0. because if qx becomes 0, we would have a 0 in the denominator. It becomes undefined. Apart from that, since both these equations are polynomials, then we can say that their domain is going to be R, apart from the values where qx is equals to 0. And range would depend on the function that has been given to you. Talking about exponential function, a to the power x, or generally the function exponential function that we use is e to the power x, right? So a, which is a constant, we call it as a base. A should always be greater than 0 and a cannot be equal to 1, because of course if it is 1, whatever be the power x, it would simply be just 1, right? Now for exponential function, what is generally our domain? Domain means the value of x that we can put. So it can be R again, minus infinity to plus infinity. We can put any value in the place of x, right? If let's say it is minus infinity, so we would have a to the power minus infinity, which can be written as 1 by a to the power infinity, which basically becomes 1 by infinity, which is 0, which is 0. So this is how the domain is defined. And when we talk about range always for an exponential function lies from 0 to infinity. So keep this thing in mind. So let's say if I was to show this to you with the help of a graph, let's say if you have a greater than 1, then your exponential function would be simply increasing in this format. Let's say if you have a less than 1 and greater than 0, that means the number of times I start exponential increasing it, what would happen? My function's value would start decreasing, right? Let's say if I have 1 by 2, if I square it, it becomes 1 by 4. That means it's getting smaller and smaller, right? So my exponential graph would be in this format. So in both these cases, you can see what is my range? It lies from 0 to infinity. Now talking about logarithmic functions, there are a few things that you need to remember. Again, whenever you have a logarithmic function where this a we call it as the base, this a should be greater than 0 and a should not be equal to 1, because if it becomes equals to 1, we would again have an undefined value, and x should be greater than 0 as it has been shown here. Now when we talk about the domain of a logarithmic function is always from 0 to infinity. That means you cannot take again negative values, right? Because we are defining x to be greater than 0. So a domain cannot be less than 0. Here what else we can see is that how can we represent this 0 to infinity? This can be written as r plus. What is this r? This is again our real numbers. And when we write a plus on top as a superscript, what do we say? This includes all positive numbers. Now this does not include 0 here. This includes all positive numbers. And when we talk about range, our range for logarithmic functions is simply r. It is going to range from minus infinity to plus infinity. Now let's say if I was to show this logarithmic function to you in a graph, this is how my logarithmic function would look like. Here what I'm assuming is that my a is greater than 1. Now let's say if my a is less than 1 but greater than 0, then what would my logarithmic function look like? It would simply become this way. So this is how logarithmic functions domain and range vary. Talking about modulus function, a modulus function is basically a function which would always give us a positive value. Whatever be the value of x inside it, we would get a positive value, right? So our domain for a modulus function would simply become r. However, our range would be r plus, and this would also include a 0 in it. If I was to write it down in a better format, this can be written as 0 to infinity, because 0 can be one of the outputs, right? So this is how domain and range are represented. And modulus x also can be represented as x if x is greater than equal to 0, and minus x if x is less than 0. Again, These are just things that you already know, you've studied in your previous classes. So just a revision of all these things. And if we were to talk about the graph of a modulus function, how does a graph of a modulus function look like? It is simply in this format. Because I hope you all know how do we write down the graph of y is equals to x. It is just a straight line passing through the origin, right? So for mod x, what happens is the part which is below the y axis, it gets mirror imaged in the x axis. So basically, if I was to write down the equation for this line, it would be y is equals to x, and this line, it would be y is equals to minus x. As you can see from these equations here, it is x when x is greater than equal to 0, and it is minus x when x is less than 0. Now talking about greatest integer function. Again, this is a thing that you already know. What is a greatest integer function? Whatever numerical value I have inside my x, it gets transformed into its integer, which is in the lower limit of it. Let's say if I have greatest integer of 5.7, what is it going to be? 5. If I have 5.3, what would it become? It would still be 5. So do not confuse yourselves that if it is 5.7, then greatest integer function would be 6. It is not like that. So keep this thing in mind. So one thing that we can say from greatest integer function is that the x that I would get, or the solution that I would get from this, would simply be less than x and greater than x minus 1. I hope you are understanding this. One thing that we can say about greatest integer function of x is, now this is my y. So y is equals to greatest integer function of x. So y would always be less than or equal to x, but it would be greater than x minus 1, of course. Now let's say if I was to talk about the domain and range of this function. So how do I write down the domain? What would be my domain? Again, I can take all values of x inside it. So it would become R. And when we talk about the range, my range would be all integers. Of course, whatever be the value inside it, I'm going to get an integer outside. So this is basically integers. So keep this thing in mind. Now let's say if I was to show this to you with the help of a graph. Let's say I have 1 here, I have 2 here, 3 here, minus 1, minus 2. Let me take these 5 values. Here we have 0 also. So when my x is ranging from 0 to 1, what is the value that I'm getting? I'm getting a 0 only, right? So I'm including 0. This is my function. Here, of course, it would be an open circle because 1 is not getting included. I cannot include 1, right? Because if I include 1, the value of greatest integer function would be 1. So this cannot be the case. Now for 2, again 2 cannot be included. However, 1 would be included. And this value that we are getting, this is basically 1. Same thing for 3 as well. Here I would have a closed circle, and at 3 I would have an open circle, and this value is 2. Similarly for minus 1, I would have an open circle here and a closed circle here. So this is my minus 1, and here I would have, let's say, my minus 2. So this would be an open circle here and it would be a closed circle here. So this is basically how the graph of integer function looks like, and this is how you are supposed to draw it. Try to frame values in your head and then put a few values. Based on that, you would be able to draw the graph of any function that you have. Now talking about a few properties of greatest integer function. Again, these are just repetitive things. So x would always be less than greatest integer function of x. Again, it is represented in this format. Sometimes you can also write greatest integer function in this way also. This is equals to this. So do not confuse yourself with the symbols we use for a greatest integer function. So again, this property is what we just learned here. So this is what we are getting. Now let's say if inside greatest integer function I have an integer added as well. So I can simply take that integer out. So if I was to show this to you with an example, let's say I have x plus m. Here my x is, let's say, 5.73 and my m is an integer, let's say 2. So this would become 5.73 plus 2, right? So if I try to add this value, what would I get? 7.73. And what would be the greatest integer function of this? It would be 7, right? Now let's say if I was to write this down in the other way, let's say if I take the integer out, I would be left with this. Again, you can see that this value would become 5 plus 2 would give us 7. Again, you can see that we are getting the same value, right? So keep this function, this property in mind. This is the most important property. This would be used a lot in other chapters as well when we solve questions which have, let's say, a little bit of concepts of greatest integer function used in them. Apart from that, all these properties you can simply just have a look at, understand, try to put in examples or numbers from your side and see if it is satisfying or not. Now again, this fourth property here, this is also another important one. Let's say you have minus x inside greatest integer function. So it would simply, you can take the minus outside and then find out your greatest integer function. That can only be the case if x is an integer. Now let's say if x is not an integer, if x is, let's say, 5.7 again. If x is 5.7, then minus 5.7's greatest integer function would be minus 5, right? So what we do is we take the minus outside. Now we have 5.7. Its greatest integer function would be 5 and we would get minus 6 as the answer. Again, the value which is lower, that becomes our answer for greatest integer function, right? So if let's say we have 5.7, what is the value lower? 5, right? So that becomes our answer. Similarly, if we have minus 5.7, what is the value lower? Minus 6. So that would become our answer. So keep this 2 points in mind as well. Apart from that, if we have GIF of x plus GIF of minus x, we can get 0 if x is an integer. If it is not an integer, we get minus 1. Again, you can put in examples from your side and see if these are the values coming out. Then it would be more clearer to you. Now again, few more properties. If let's say greatest integer function is greater than n, then what can we say about x? It would be greater than equal to n plus 1, where n belongs to an integer. So keep this in mind as well. Now let's say if we have x less than n, so it would be simply x less than n. Now one more property that you need to keep in mind. This is a property which you would understand more properly when you study sequence and series. But still, for the timing, I would say you just remember this property. It is, let's say if you have a series given to you. Let's say you have x plus 1 by n plus x plus 2 by n plus x plus 3 by n. All these are under greatest integer function. So keep this thing in mind. And this goes on up till we have x plus n minus 1 upon n. Again, remember this thing. We are not going up till n, because if we go up till n, it would become x plus 1 and we would have some other value that we are going to get. So it is only up till n minus 1. So what would be the answer for this? You can simply directly write it down as n into x greatest integer function. Here, my n belongs to integers. So keep this thing in mind. Now, if you look at the number of terms that are in this entire series, here we had basically x plus 0 by n. This is what we had, right, in this position. So I have to count this as 1. So I have to start my numbering from here. This would become 2. This would become 3. and simply n minus 1 would become n. So basically there are n number of terms in this series. So keep this formula in mind so that whenever you solve questions, it becomes easier for you to solve them. Now talking about fractional part function. Fractional part is for greatest integer function, what we used to do is whatever value we had of x, we used to take only the integer portion of that. Now for fractional function, what we do is we take only the fractional part of it. So basically fractional part of x can be written as x minus bracketed x. Let's say if I have fractional part of 5.73. So what would it become? It would simply become 0.73. So this is my fractional part. Now let's say if you had minus 5.7, then what would be your fractional part? Now your fractional part would not be 0.7. It would become 0.3. And remember one thing, your fractional part can never be 0. Sorry, can never be negative. It can be 0. Of course, whenever we have integers, your fractional part is 0 there. However, it cannot be negative anytime. So if you try to put these values in this formula, let's say if I am finding fractional part of minus 5.7. So it can be written as minus 5.7 minus of minus 5.7. So from here, what do we get? Minus 5.7 minus and minus 5.7. What is its greatest integer function going to be? It is going to be minus 6. So we would have minus 6 here. This would simply make it plus 6. And if you try to add this up, you would get 0.3. So that is how you get fractional part of negative numbers as well. Now again, if I was to define the domain and range for fractional parts, my domain would be all real numbers and my range would simply be from 0 to 1. Of course, my fractional part cannot be equal to 1, because if it is 1, it is not a fractional part, right? It becomes an integer now. So my range is always 0 to 1. And if I was to show this to you with the help of a graph, let's say I have 0 here. Let me take a few more values, 1, 2, and 3. Here I have 1. I have minus 1 and minus 2. Now, let's say if my value is ranging from 0 to 1, what would my fractional part become? Again, I cannot include 1, neither can I include 1 in the y-axis because it is going to be an open circle. So this would be my graph. Basically, it is a straight line. I hope you are understanding it, because for this portion, my greatest integer function would simply become equal to the integer. The integer portion would be struck off and we would have a y is equals to x curve for the first part. Now for the second one, again, you can never have the integer. Let's say if I put x as 1 point something, what is my fractional part going to be? It is again going to be the fraction that is inside it. So here I would include this one, because here I would have a 0. The value of y when I have 1, let's say if I have 1 here. So what is the fractional part of this? 0. So I would get a 0, right? So I have to, at 1 also my value is 0. However, I cannot include my value at 2. So this is the way. Similarly, for here as well, it would be an open circle here and a closed circle here, an open circle here and a closed circle here. So this is how you represent the graph of a fractional part. Talking about signum function, another type of function. What happens with this function is you get only 3 outputs, which is either 1, either 0 or minus 1. So there are only 3 outputs. So basically what I'm saying is, what is my range for this type of function? My range is basically 0, 1 and minus 1. So these are the 3 values that I can get only in range. Now when I talk about the domain, it can be R. again, I can put any value of x inside it. I'm going to get my output as either 0, 1 or minus 1. So whenever my x is greater than 0, I would get the value as 1. Whenever x is equal to 0, I would get my output as 0. Whenever x is less than 0, I would get my output as minus 1. So now if I was to show this with the help of a graph, let's say this is my graph. At 0, what am I getting my value? At 0, x, my y is also 0. So there will be a closed circle here. And this is my y, which is 1. So apart from 0, all positive values, I would get my value as 1. So this would be a straight line here. And here, let's say if I have minus 1, this is the value how I am getting. So this would be my graph for a signum function. Now, before we move on to the next topic, just one more thing that I forgot to tell you about fractional part. Again, these are a few properties that you must remember. Let's say if you have in the fractional part x plus n. Here n belongs to integers. So keep this thing in mind, or we can write it as z as well. So what would be the answer here? The answer would simply be x. Because of course, addition of any integer does not affect the value of my fractional part which is inside it, right? So it can be written in this format. And let's say if I have fractional part of x plus minus of x, so what would be the value of this? Again, we would get two values. One would be 0 when x belongs to integers, and we would get 1 when x does not belong to integers. So keep these two properties in mind as well, and do not confuse this property with the one that we studied in greatest integer function. Greatest integer function plus minus of that would give us 0 if it is an integer, and we would get minus 1 otherwise. Here we are getting 1 when it is not an integer. 0 is the same again. So these are two properties which are the most important for fractional part that you must know.